The next question of lead code weekly contest 377 is minimum cost to convert string 1. So basically in this question, we are given two strings, source and target. So source has all characters in lowercase and target is also in lowercase. Now we are given some changes that can be performed. They are listed in the form of original. So original has all the initial characters. Changed will have how we can change this character to, like, to what character can we change the original character to. That's what this list has. And for each change, for ith change, cost of I will tell us what is the cost that is required to change original character to the changed character. So this is what is given. Now our aim is to convert source to target by applying these following changes if required. So we can apply these changes. So we need to say what should be the minimum cost to convert source to target by applying what should be the minimum cost to make source equal to target by applying some of these changes if required. That is original to changed. We can just change characters. And in case if it's impossible to convert source to target, then we should output -1. So if you look at the constraints, source length of string sources can be in the range 1 to 10 power 5. Length of string target can be in the range 1 to 10 power 5. Now we have two lists, original and changed. So these two things can have a length of 1 to 2000 and cost can be, cost of I will be in the range 1 to 10 power 6. And it's guaranteed that original of I will never be equal to changed of I. So now let's see how we can solve this. So if we look over these dependencies, we can observe that it is it looks like a graph problem. Okay? So basically, let us maintain the minimum cost. What is the minimum cost that we need to change? Firstly, let's define min cost as the minimum cost required to change character 1 to character 2. If in case it's not possible to change, let's put it as some infinite value. So, uh, so basically min cost of character 1 to character 2 tells us what is the minimum cost required to change character 1 to character 2. So for that, what we can do is, so now our aim is to compute this. So if we look over the base condition for this would be I of I will be 0 because same character we doesn't need any operations, right, to change. So I of I, we can say it is 0. Now if we want to perform, yeah, now we already know single dependency, that is cost of original of I, changing from original of I to changed of I. We need a total, we need cost amount, we need cost amount, and there can be multiple original I to change die with minimum cost. So we can just be like minimum of I changed of I. So currently this is our base, that is changing a character to itself is 0, and changing original character to a particular character is that is already given, like original of I to changed of I, what is the cost is given. So we can even have redundant values in it, that is we can have multiple same original and changed I with different cost. In that scenario it's always optimal to pick the cost with smaller the thing with smallest cost, right? So that is why we are setting original I to changed of I to the smallest cost. Now we have the cost to directly change a character to other character, but sometimes it would be beneficial for us to change A to B. Basically, let's say we want to change character A directly to D. Now A to D costs us some 10 units, but it is possible to change A to B, B to C, and C to D. So converting A to B will cost us 1 unit, B to C will cost us 2, C to D will cost us 3. If we look over going with this path, though we are making more changes, since the cost is less, going through this path would be beneficial, right? So which would cost us only 6 units. So now to compute the minimum cost required to change A to uh, required to change original of I to changed of I, using any number of paths, uh, using different paths also, as we saw just now, the edge case that we can have can be computed by looking this problem as a graph problem. That is, we can consider each character has edges to other character. So basically, we can consider that each character has edges with certain weights to other characters. Now our aim is to travel through these edges and find out the optimal path, that is which will cost us less amount. So for that we can do Floyard version. So before watching this editorial, if you guys are uncomfortable with Floyard version, first learn Floyard version and then resume it from this point, because the prerequisite for this is Floyard version. So now Floyard version is just doing dynamic programming. So we are just doing DP on this. So finally, after performing Floyard version, like the way we can perform Floyard version is we already have the base condition here. So now let's fix a character. It can range from 0 to 25. Now let's fix I, then let's fix J, 0 to 25. So now we need to compute minimum cost. So transitions will look like we need to compute minimum cost of I to J. Then we can just if we already know the answer of minimum cost of I to K and K to J, then our value would be, and then our transition could be minimum cost to make character I to J, comma min cost to make character I to K, Then from K, we are making it to min cost from K to J. Right? So ultimately, this one plus this one will be minimum cost required to change character I to J. Right? So this way, if we make the transitions, then finally, after performing all this for every fixed K, we can guarantee that we'll have the minimum distance from I to K for sure. Right? So what is the minimum distance from I to K? Because if we observe, we are just doing dynamic programming here. At each step, we are finding out the uh, value considering K as the medium for I to J, like K as the medium to travel from I to J. So this is how we are computing. This is how we are making the transition. So this is just a standard Floyard version. Whatever we did here. So once we do this, we'll have the minimum cost to convert character I to character J. Then we can just iterate a loop over source, every character of source. So now, in case if there is any ith position where uh, source of I is not equal to target of I, then the minimum cost we need to convert this source of I to target of I is, we already computed that. So it would be min cost of source of I to target of I. Sum of all such values will be the minimum cost that we get. And in case this min cost of source of I of target of I is not possible, that is to detect that we put a higher value while doing flow because we are setting the value to minimum. So if we put a higher value, then in case the final min cost of source of I to target of I is higher, then we can say that for now let's assume we kept infinity. Then if min cost of source of I of target of I is infinity, then we can guarantee that there is no path from source of I to target of I. So if at any point there doesn't exist any path, that is if this is infinity, we are detecting that by putting some infinite value, some infinite in the sense we can set it depending on the constraints. So for now, let's assume it as infinity. So at any point this goes infinity, then we can guarantee that there is no path. So -1 would be the output. Otherwise, otherwise we are just summing up all the costs to convert source to target. So answer will be our value. So basically we just found out the minimum cost required to change character I to J. And then for all source of I, target of I, which are different, we should change source of I to target of I. So we already know the minimum cost, which we computed using Floyard version. And we are just adding that cost up. So some of that cost will be the minimum possible cost to convert source of I to target of source to target. So if you look over the time complexity of this, so time complexity of this would be big O of we are basically iterating over source. It would be source dot length plus O dot length plus we can say it's 26 cube because here in our graph characters are the nodes and we are performing Floyard version on the characters. So 26 cube will be the time complexity of Floyard version as there are 26 nodes. And if you look over the space complexity would be big of 26 square. So these are per test case. So with this time and space complexity, we can solve it.